Hi and welcome to K-Mix. Today we'll give you a demo of the K-Mix Industrial Fluid Mixer Design software. K-Mix provides performance predictions for single-phase and multi-phase stirred reactors. It gives immediate results when you design stirred fluid mixing vessels. You do not need any complicated 3D modeling, and you do not need any special hardware, just your Windows PC. Let's have a look at the software itself. Here we see the K-Mix user interface. On the top it has the usual menu bar and ribbon. The panel on the left-hand side has tabs where you can enter the information about your design. For example, the vessel information, process details, liquid properties, the impellers, solids, gas spargers, and so on. We'll use metric units now, but it's very easy to switch back and forth between metric and US customary units. In the panel on the right-hand side we have the tabs with the program outputs. The drawing shows the vessel, liquid level, and the impellers and their pumping directions. The detailed report has all the information about your design, and this report can also be sent to Microsoft Office applications such as Excel and Word. Other tabs show more detailed results such as the various loads, power draw, mechanical results, blend time data, solid suspension information, gas dispersion results, heat transfer rates, and dimensionless numbers. Let's look at some examples. We can select different designs from the design list at the bottom. Here we see an aerobic fermentation system. It has a disc turbine at the bottom and two wide-blade hydrofoil impellers above. A ring sparger is used to supply the gas. K-Mix reports gas power draw, gas holdup, and mass transfer rates. You can also use K-Mix for glass-lined equipment, which is characterized by the impellers and baffles having rounded edges and the baffles usually being suspended from the top head instead of being attached to the walls. K-Mix can also design viscous mixers, as in this example that has two different shafts, one with a helical ribbon and an auger, and a second shaft with a high-speed disperser. Advanced thermal calculations are possible also. Here we see a heat exchanger vessel with multiple impellers. It is equipped with helical coils for cooling. K-Mix will predict the heat transfer rates. This is a hydrofoil impeller design for solid suspension in a tall vessel. Particle diameter can be specified or it can be calculated from a particle size distribution. K-Mix predicts just suspended speed, settled solids fraction, cloud height, mass transfer rate, and dissolving time. This design has a rectangular vessel with a sloped bottom and two down-angled side-entering impellers. And here we see a horizontal cylindrical vessel with three different impellers on three different shafts. This design has two shafts, and for each shaft K-Mix performed the required mechanical design calculations including critical speed and stresses. Shafts are not always top-entering and vertical. They can certainly be off-center, bottom-entering, or angled as shown here. For this batch dispersion vessel equipped with a disc turbine, a secondary liquid is specified that is immiscible with the primary liquid. In that case, K-Mix's liquid dispersion calculations include droplet size and the time required to complete the dispersion process. For selected system geometries, K-Mix can also calculate surface vortex depth. The vortex shape is then shown in the drawing. Surface vortices are most often encountered in systems with either no baffles or with partial baffles as shown here. Available viscosity models are Newtonian, power law, and yield stress fluids. Yield stress fluids may form stagnant zones. In caverns around the impellers, the fluid moves because the shear stress exceeds the yield stress. Outside the cavern, the fluid is stagnant and does not move at all. K-Mix calculates the cavern sizes and stagnant zones and depicts them in the drawing. In this example, adding additional impellers resolves the stagnant zones and the fluid then moves everywhere. For sanitary applications, magnetically driven mixers are often used. K-Mix offers both axial flow and radial flow magnetic impellers. High-speed rotor stator devices are used to break up agglomerates or to create fine dispersions or emulsions. A wide variety of stator geometries is available. It is also possible to calibrate the K-Mix results for these systems. Conical vessels may be used. The smaller diameter in the lower section helps with maintaining liquid levels and agitation while the vessel is being drained. Multi-level vessels are used for the same reason. Stage dividers are used in some processes to create different chemical reaction compartments in the vessel. In this design, each stage has its own impeller and gas sparger. Draft tubes are sometimes used to help with the circulation in tall vessels. Here a vessel with a draft tube, and both a bottom-entering sweeper impeller and a top-entering hydrofoil impeller is shown. Another option for viscous systems is to create your own custom frame or anchor by combining different plate, arm, and blade types. Those were some prepared examples. Now let's just set up our own case and see how that works in K-Mix. We'll close this file and start a new design. The default design is just a single impeller in a vertical cylindrical vessel. We can edit this. Maybe the vessel is 0.9 meter and the straight side is 1.3 meter. There is a large choice of bottom and top head shapes. There's other information that can be entered, such as vessel material and wall thickness. We don't need to specify these details now, those are most important for heat transfer calculations. Here we'll specify the operating conditions. If we enter an operating level, K-Mix will calculate the operating volume and vice versa. The operating level is shown in the drawing. Operating temperature and pressure are to be set also, and you can choose if this is a batch system or a continuous flow system with a specified flow rate. For this example, we'll stay with a batch system. Next, we will specify the liquids. We can choose a primary liquid from the drop-down list which contains a number of common materials, or we can enter our own liquid name, density, and viscous properties. It is also possible to specify a secondary liquid. If there is a large density difference between the two liquids, then that may affect blend time, and that information will be included in the blend time report. Also, if the liquids are immiscible, droplets may form, and in that case K-Mix can provide droplet diameter and dispersion time. We can now specify the drive system. You can have up to 4 drives. Each drive consists of a motor, gearbox, and shaft. They can be top-entering, bottom-entering, or side-entering. Drop-down lists with standard motor powers and RPMs are available. So, for each drive you can specify the motor power, the rotational speed, shaft information, off-center distance, and shaft angle. K-Mix can design the shaft for you, or you can specify it yourself. Shafts can be solid or hollow, cylindrical or square. If needed, they can have steady bearings also. We will now look at the impeller system. You can have up to 8 sets of impellers, and for each impeller set you can specify which drive it is attached to. In K-Mix, impellers are grouped by style, and under each style, a number of different impeller types are available. Styles include general impellers, disc turbines, glass-lined, viscous impellers, dispersers, rotor stators, counterflow impellers, magnetic and specialty impellers, as well as selected commercial impellers. After you choose the style, you can then click on the type drop-down list. This shows you visually the available types. For example, under General you will find various hydrofoils, pitched blade, and straight blade turbines. Here we select a glass-lined impeller, and K-Mix then automatically matched glass-lined baffles to this impeller. An easy way to create a new impeller system is to use K-Mix's unique quick agitator design feature. This allows you to choose the kind of system you'd like to use. You can set the blending scale of agitation M scale you'd like on a 1 to 10 scale from slow to very powerful. Let's specify a hydrofoil system with a medium scale of agitation. Click Design. Now we see that K-Mix has created a new design with multiple impellers spaced over the liquid level. K-Mix also designed the drive and shaft, and set the motor power and rotational speed. We now enable the mechanical design calculations. K-Mix will then report the shaft critical speed and the shaft stresses as a percentage of the maximum allowable stresses. This information is then added to drawing captions, and it is also included in the Results Summary tab. Detailed results can be viewed in the nicely detailed report. It has all the user inputs, calculation results, and program messages. This can also be sent straight to Office programs such as Excel. When you do so, you'll notice that it comes in with a clean layout and nicely formatted tables, although unformatted text output is available also if needed. We have now come to the end of our demonstration. Although we have looked at a lot, KMix still has many more features that will help you with your agitator designs. For more information, contact us by email at support@kmixllc.com or visit the website at kmixllc.com. Enjoy!